Okay, so we just said the variable to be explained we call dependent variable, or DV as a shorthand, and the variable that is manipulated and the variable that represents the presumed cause we call independent variable, or IV. So you might wonder why we're calling these variable these names. The reason is this. We call the variable to be explained the dependent variable because, as we just explained, its value, for example, how friendly we'll perceive Mike, will be dependent on the value that the independent variable in the personal warmth in our previous example would take, either warm or cold, right? Depending on whether in the personal warmth this variable takes the value of warm or takes the value of cold, the value of the dependent variable will change. That's why it is called a dependent variable. And we called the other variable, the variable that is to be manipulated, independent variable, because its value does not depend on this variable or any other variable in experiment, right? Because there's a causal relationship here. This the cause, this the effect. We say cause, effect, cause, effect. Of course, the effect depends on the cause, but the cause should not be dependent on the effect, right? So that's why we call this variable independent variable. Its value not being dependent on any other variables in the experiment. Okay? So in other words, dependence or independence really describes how these two variables are related, or their position or function in the hypothesis, right? Which is the cause, which is the effect. The effect will be represented by dependent variable, or dV. The cause will be represented by the independent variable, or IV. But of course, it would say, um, other than the manipulation, there could be many other reasons why we perceive a person as more or less friendly. Okay, um, you know, it is possible, right? Some people are naturally overestimators. That is, these people, by their personality, tend to overperceive or overestimate a particular quality of a person, right? And you know, some, whereas other individuals are naturally underestimators. That is, they tend to overestimate a particular quality of the individual. So that is regardless our manipulation, right? Anchor size here simply means, the value that we assign to different conditions. Some people would just, regardless the manipulation, some people will overestimate or overperceive the probability that Mike is more or less friendly. Okay? So the question, of course, is how do we rule out this possibility? How do we handle this critique, imagining that this critique is from a colleague or a reviewer if you submit your paper for publication, right? That is, hey, other than your manipulation, there could be some other causes that results in the effects that you just observe. So you cannot confidently say that it is because of your manipulation that results in the effect. There could be alternative explanations, right? How do we handle this? The way that experiments sort of naturally handles this kinds of critique is by a process that we call randomization. Okay, so the beauty of randomization, which we'll define in a minute, is that it would reduce the influence of the personality effects of participants to as small as possible. Okay? So by randomization, we mean that we randomly allocate participant into either one of the conditions. In other words, every participant, they have an equal chance to be assigned to the warm condition or to be assigned to the cold condition. So before they take part in the actual experiment, before they're assigned to a condition, they don't know which condition they're assigned to because the probability is the same, right? In this case, you'll be half exactly, right? Half the time they will be assigned to the warm condition, but it's just equally possible that will be assigned, this person will be assigned to the cold condition. So this is called random assignment, right? So what random assignment can achieve is you can imagine that through this randomization process or random assignment, right? Um, People of different personalities, overestimators, underestimators, extroverts or introverts, they will be equally likely be assigned to the two conditions, right? And another way to think about it is you have X amount of extroverts, Y amounts of introverts, and through this randomization process, between the two conditions, right, you will have roughly equal amount of extroverts and introverts, so that um, the personality traits would not be a factor that could confound our results. So this might sound a little bit abstract. That's okay. Let's make it more concrete. Okay. Mm, Again, let's end the slideshow. And what do we do? And let's create another empty slide or blank slide. Please hang on a second. Okay. Okay, here we go. So imagine, right, we have two conditions. This is condition 1, this is condition 2, and to stick to with our example experiment, this is the warm condition, this is the cold condition. Okay, and now we have a bunch of participants. This is our pool of participants, and our job, of course, is to randomly allocate this pool of participants to this group or this group. So let's say in this pool of participants, we have two types of people. There are extroverts, there are introverts, extroverts, 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 introverts, introverts, introverts. Okay, so we have 5 extroverts and 5 introverts. Well, to make things easier, let's have an even number. So 6 extroverts, 6 introverts. So the idea is that extroverts, a characteristic of extroverts is these people are very outgoing and they're going to see anybody as friendly. Compared to introverts, they're a little bit shy and they're not going to perceive other people as friendly as extroverts will do. So, in other words, other than describing the target person as differentially being warm or cold, personality traits can also impact how participants perceive Mike as in terms of his friendliness. Okay, so let's first see what will happen if we don't do random assignment. That is, we put all individuals, right, in one condition. We put all extroverts in one condition, and we put all the introverts in a second condition. So yes, we must still see some difference as a result of the manipulation of warm versus cold, but you can quickly point out that, hey, Andrew, wait a minute. Any difference between these two groups might not be caused by your manipulation of interpersonal warmth, but because naturally these extroverted individuals will perceive anyone as more friendly than this group of people who are all introverts. And because of this, you're not certain whether the results or the effect that you observe is because of people's personality traits or because of the manipulation that you just introduced. So that's a big problem. Okay? To solve this problem, right, we need randomization. We rely on this process that we call random assignment to sort of reshuffle extroverts and introverts into these two groups. So one way to do that is to flip a coin, right? We say, well, heads will go to the warm condition and tail will go to the cold condition, right? The cold condition. And, the flipping coin will be a random process because you don't have control whether, well, that is unless you're practiced, right? So normally you don't have control whether you're going to get a head or tails, right? So get a heads, so this will go here. Turns out that the second time you flip a coin, you have a tail, so you get an introvert. Third time you have another tail, you get another introvert. But then for the next few times, you have heads, and a tail. So you can see by repeating this process, right? And if our sample size, that is the pool of participants, are large enough, so eventually, the two conditions in the end, if we follow closely the procedure of random assignment, will have roughly equal amounts of extroverts and introverts in both conditions. And because the effects of these opposing personality traits will cancel each other out, right? So the effects of extroverts will be canceled by the introverts here, and the effect of extroverts will be canceled by the effect of introverts here. Then what is left will certainly be and must be the effect of the manipulation that we just introduced, describing Mike as warm or cold. Okay, so this is the idea why randomization or random assignment is important. Okay, all right, let's resume our class. So now, after introducing the basic elements of experiments, we can start to answer this question, and that is, why can experiments establish causality? Because recall, at the very start of this class, we said that experiments, the distinguishing feature of experiments is that you can establish causality. which survey studies cannot do. Okay? But the question, of course, is why can experiments do that? To answer this question, we need to revisit the three criteria of causality. So if you recall from the first one-third of our class, the three criteria of establishing causality is that given our presumed causal relationship, A causes B, right? First of all, we must be able to establish that A is related to B, that is association. The second criterion is that for for us to be able to claim that A causes B, we must be able to establish that A must occur prior to B. That is the requirement of temporality, because cause effect, cause must always happen before effects takes place. The third criterion is there are no alternative explanations. That is, the presence of A must lead to the presence of B, and absence of A will lead to the absence of B. Because if there are other alternative explanations, then even if you take out or remove A, B might still be present because of confounds, right? So by ruling out confounds, we'll be able to confidently claim that it is indeed A causes B. In other words, if these are the three criteria of established causality, and if we say that experiments can establish causality, it follows that experiments are able to meet these three criteria. Okay, this must be the case because these are the logical requirements to establish causality, and if experiments are capable of establishing causality, then it must be the case that experiments can fulfill the three criteria. How is that so? Well, first of all, experiments can of course establish association because, as we just said, right, an experiment needs at least two variables, an independent variable and a dependent variable. And with two variables, we can easily establish correlation. Okay? Temporality. Experiments are capable of establishing temporality because independent variables, the variables that represent the presumed cause, are always manipulated before we measure the dependent variables or the variables that represent the intended effects. And that's exactly why manipulation is such an essential feature in experiment, because if you simply ask people to report, for example, how many hours they spend studying, this report can actually come after they report a value for the DV, for example, their GPA. So in that case, GPA actually come first and the time they spend on studying come later. For example, a person might reason, well, I don't actually remember how much time I spent studying, but because when I look at my transcript, I have a pretty good, GPA, that must mean I have spent lots of time studying. See, in this example, time spent studying actually come after the variable we tend to explain. And that certainly violates the requirement of temporality. So that's why we cannot rely on self-reports of independent variables to establish causality. We must manipulate the independent variable at the spot, right? We make people to study for different amounts of times. Then we measure their performance, academic performance, right? So studying for different amounts of time happens first, and then we measure their performance in a certain kind of test. So that way, we'll be able to make sure that indeed the cause, time spent studying, happens first and the performance follows. And this is the same for our example experiment based on ASH study, right? We have two groups of people read the description of Mike first, and then we have them estimate how friendly Mike is. So description of warm versus cold come first, followed by the perception of Mike in terms of his friendliness. So cause, the manipulation happens first and the effect happens later. And we just said, right, one way to establish causality and to rule out alternative explanations is through randomization. That is, we randomly assign individuals into different conditions. And we just demonstrated that, through a very simple thought experiment or exercise, right? By randomly assigned extroverts and introverts into the two conditions, over time and with large enough sample size, we'll be able to make sure that roughly the two conditions contain equal amounts of extroverts and introverts. And because each group has equal amounts of extroverts and introverts, the effect of personality traits, the effect of extroversion versus introversion, right, will cancel each other out. And therefore, this potential confound of personality traits will be ruled out, and that's ruling out one important source of confounds. So that's why randomization is important and helpful in establishing causality. But at the same time, in addition to random assignment, we need a second very critical aspect of the experiment to rule out confounds. And that second requirement is clean manipulation. What does it mean? Well, unfortunately, we don't really have a very good definition of clean manipulation, and in many cases, especially in social science, whether a manipulation is clean or not is a judgment call, right? So, if we recall the example experiment based on Ash's study, we'll say that is a pretty clean experiment because we, describe Mike with, I think, 10 adjectives, and 9 adjectives are identical across two conditions, being competent, being industrious, being intelligent, etc., right? All those adjectives are the same across two conditions, and the only difference occurs between warm versus cold. So that's the only changing element. So that suggests it is pretty clean. In other words, we're not changing multiple elements with one procedure, with one manipulation. Okay? In other words, for a manipulation to be clean, one manipulation can only change one element. So with one manipulation, you can of course change the person description from Mike being warm to Mike being cold. And you cannot do anything more. If you want to change other aspects of the description, you must introduce a second manipulation, right? For example, this is our example, right? Competent, skillful, industrious, determined, practical, cautious, they're identical. The only difference is warm versus cold. So that is one manipulation, and this one manipulation results in one change. So that's good, right? In this case, the one procedure is person description. In this case, the one element that's being changed is interpersonal warmth. In one condition, this manipulated variable takes the value of warm, and in the second condition, this manipulated variable takes the value of cold. So that's clean manipulation. One procedure, one manipulation changes one condition. But let's imagine if in this experiment, and for the first group of participants, I present the following description. Mike is competent, skillful, industrious, warm, determined, practical, and cautious. And to the second group of participants, I describe Mike as incompetent, skillful, industrious, cold, determined, practical, and cautious. What is the problem? What is the problem? The problem, of course, you might have already guessed, is that the manipulation is not clean. Because with one manipulation, right, there's only two conditions here that suggest there must be only one change, right? We change from this condition to this condition, therefore only one manipulation here. And with this one procedure, we changed two aspects: warm versus cold, competent versus incompetent. Right? That's what we said. The manipulation of interpersonal warmth from warm to cold is confounded or is manipulated at the same time as the manipulation of how competent Mike is. Competent versus incompetent. Okay? So that way, any change in the perception of Mike could be due to the manipulation of Mike's warmth, or it could be due to the manipulation of Mike's competency. And because the two manipulations, the manipulation of warmth and the manipulation of competency, happens at the same time, we'll not be able to determine whether it is this manipulation or that manipulation or both manipulations results in any change in the perception of Mike's friendliness. We simply don't know. Okay? So that way, we'll not be able to establish any kinds of causality because there are confounds. And the confounds is due to the manipulation of these two variables at the same time. Right? This is variable because it takes the value of warm versus cold. This is also variable because it takes the value of competent versus incompetent. Once the two manipulations occurs at the same time, they confound each other and makes it impossible to determine which one causes the intended effect. Okay? So that simply suggests, for any experiment, we change one aspect at a time. We want a second manipulation, we want a second change, perform a second manipulation. We want a third change, perform a third manipulation. And that's the only way to establish causality, to rule out confounding variables or alternative explanations. Okay?